So let's think about the strategy we'll follow when we're doing Newton's second law, rotational dynamics problems, involving both forces and torques. The first thing we need to do is identify our system and all the forces that act on it. Once we know the system and the forces, we will draw a free body diagram, and then we will look and choose a coordinate system. At that point, we calculate or find expressions for all of the torques. Remember, we've already got the forces, but we need to figure out what kinds of torques are they causing. Some forces may not cause any torque, some forces may cause a lot of torque. And lastly, we're going to apply Newton's second law in translational and rotational forms. In other words, we're going to do F equals ma, and we will do torque equals I alpha. So, let's look at the problem we've just seen before. As it rolls down the incline, I've got this backwards. I'll redraw this picture in a moment because the normal force is, that picture is all based on a slope that goes the other way. And I just realized that now. So let's put this here. So if I look at the object rolling down the hill, I've got all the forces I would on a block. I've got a weight, mg, pulling down. I've got a normal force that goes from the surface, where it makes contact, through the center of mass, perpendicular to the surface. That's my normal force. And I've got friction force. A lot of people forget there's a friction when we're rolling down a ramp like this, but that friction has to be there to make it rotate. Okay, and notice we've drawn this so that they each show where they act. Normal force acts at the contact point, gravity acts at the center of mass, frictional force acts along the surface. Okay, so we've identified the forces, we've identified where they act, we've drawn a free body diagram, an extended free body diagram, and now we need to choose a coordinate system. Now, I'm going to solve this in two different coordinate systems. One's going to have the axis right there at the center of mass and have a y direction perpendicular to the surface and an x direction down the surface. The other one will place the axis of rotation right there. I'll get to that in a moment. But now we can write down torques for each one of these and use that to determine our force equations, both rotational and translational. So before we go figuring out the torques due to each of these forces, I want to take just a brief moment to break gravity down into its components. So gravity has a component into the board, into the surface, and a component along the surface. This angle up here we already know is the angle theta, same as this one here, or this one here. And that means the term into the board is mg cosine theta. The term along the board is mg sine theta. So group this all together.